Hello, this is Fahad from Game Code Bytes. Today I'm going to show you how to build something like this with JavaScript. I've seen this mechanism a lot in video games where you have a circle that moves over another circle, and it can also jump over that circle. So basically there is some gravity force between the small one and the big one, and the small one is going to move over the big circle and can jump as well. Now, this is probably going to be separated into two videos. So let's get started. Okay, so I created a simple boilerplate to have all of the things we need to do over and over again. And I don't want to do that while recording because I don't want to waste your time seeing me doing this over and over again. All what I did is I created a folder called circle on globe, and then there are three files within that folder: index.html and index.js and style.css. Index.html, I created a canvas element with an ID of canvas, and I'm also having a reference to our JavaScript code. And the style.css, where we're simply adding a bunch of styles for the HTML body on the canvas. Now in index.js, I got a reference to the canvas by saying document.get element by ID, and then I create a context object so I can draw on the canvas, and I'm also setting the canvas width and height and assign those values into two constants, width and height, and I'm also pushing the canvas from the top to be in the middle of the screen. Now we need to create a blueprint, like a class of a circle, so that we just create an object of a circle saying, okay, create a small circle, and then we'll pass a radius of, let's say, 25. And then we can create another circle and saying a radius of 100 or like 150. So let's create this blueprint. So I'll say circle. And then this circle is going to take a bunch of params. We'll say x and y and radius and color as well. Then we'll say this dot x equals x, this dot y equals y, this dot r, which is the radius, equals r. And same goes for the color. Okay. And we also want to make sure that when you want to implement this function, when you want to call it, you have to use new with it because it behaves just like a class. So we'll say if not new.target, then we'll throw a new error saying you must use new. Just a simple message here. Now, I like to create a separate function for update and another function for draw. So let's do that. So let's create a function called update, and then another function called, we can either call it draw or render. Let's use render for now. Okay. Now we also need to request animation frame, and we'll use this function frame, and then here we'll say request animation frame, and this is going to call itself, and then here we'll say call the update first and then render. And also in the render we want to clear the context on every frame. Note that this is not a good practice to do this. You should only clear what you have updated on the canvas. But for the sake of keeping things simple, I'm just going to clear the rectangle, the canvas on every frame. So we'll say 0, 0, and width of the canvas and the height of the canvas. Okay. Okay, now we need to create an array of circles, and then every time we create a new circle, we will push that circle into that array, and then we use that array to loop through all of the circles and draw them on the canvas in the render function. So let's do that. So I'll say const circles equals a new array, and then every time we create a circle, we'll say circles.push this. Now in the render function, we'll say circles.forEach, and to keep things a little bit short, I'll say C instead of circle. And then we need to say context.fill style equals C.color and context.arc. That's how we draw a circle using the context object. And we need to pass X and Y and the radius, and also we need to say math.pi, math.pi by 2, because a full circle is pi by 2. A half circle is pi. And then we need to finally say context.fill. Okay. Now we also need to call the frame function. Once we call the frame function for one time only, it's going to do this forever, do this logic forever. Call update, call render, and then request animation frame and pass itself as a callback. Now let's create the big circle first. We'll say const big circle equals a new circle, and then I'm going to say 150 for its X position, and for Y let's use 200, and for the radius let's use 80, and the color I'm just going to use blue. If I save this, we should be able to see a blue circle on the canvas. Let's try it out. Nice. Now let's quickly rename big circle to be globe, and also I'm going to create another circle, the small circle actually, and I'm just going to use the name circle. Oh, what I'm doing here. And then X 100, Y 100, and let's use 20, and color is going to be orange. I can't even type. Okay. Now probably if I save this, we're going to see two orange colors. And that's because we need to, yes, exactly. And that's because we need to say context.begin path, and then we need to close it here. Dot close path. This should fix it. So now we have two circles drawn on the canvas. Now the next thing I want to do is to create the force of gravity between the big circle, which is, in our case we called it globe, and the small one. And to do that, first of all, we need to create a gravity object. And it's going to hold X and Y. So gravity is going to be on the X and Y axes, not only Y. And also we need velocity in this circle. Every time we create a new circle, we need to have a velocity. So this dot vel equals, it's going to be on the Y and the X axes. Now we need to find the direction from the small circle and the globe. And to do that, first of all, we need to say const dx, which is the difference in the x-axis position between the globe and the small circle. So equals globe.x minus circle.x, and same on y, globe.y minus circle.y. And then we can also find the direction between the small circle and the big one by saying direction equals math.atan2 dy dx. So this will give us the direction from the small circle to the big one. And also we can find the distance because we need that for the collision detection. So we'll say distance, or d, equals math.square root dx by dx plus dy by dy. Now dx is the difference on the x-axis position between the two circles. This is dx. And dy is the difference on the y-axis between the two circles. So this is dy, this is dx, and we need to find out the distance between them, or the magnitude. And to find out this line, which is the distance between the two circles, we will use something called Pythagoras theorem. And that's it. Next, we can find the force of gravity using these information. And to do that, we'll say gravity.x equals math.cosine. So we need the x component of that direction. So it's going to be dir, and gravity.y equals math.sine of a direction. And here we're finding the y component of that direction. Now we have the gravity on the x and y axes as a force. Let's add that to the velocity of the circle. So I'll say circle.x.vil.x plus equals gravity.x, and circle.vil.y plus equals gravity.y. Then we need to add that to the position of the circle. So I'll say circle.x plus equal circle.vil.x, and same goes for y, circle.vil.y. Let's test this out and see. Okay. Now this is a nice effect, but it isn't what we want to do. We want the circle to land on the globe every time it touches it. So we need to create a collision detection. We need to detect if there is a collision between the small circle and the globe. And to do that, we'll say if d is less than globe.r plus circle.r. And also we can create a constant and say sum radii, or we can just say radii equals, which is the summation of the radius of the two circles. And we'll say globe.r plus circle.r. Then here, instead of saying this, we'll say if d is less than radii, that means there is a collision detection. Now, how do we find out if there is a collision between the two circles? To do that, we need to understand that there is something called radius in every circle. And the radius is this line going from the middle of the circle to any edge on the circle. Same goes on the other circle as well. Now, to find out if there is a collision, we would say that if the distance between the two circles is less than the sum of radii, which is the summation of the radius of this circle and this circle. If the distance is less than the sum of these lines, that means there is a collision. So let's test something. If there is a collision, let's throw the ball in a different position, or the circle. So I'll say circle.x equals 0, circle.y equals 0, and see. Okay, so there is a collision. Now we have verified that the collision detection is working. Now we need to respond to that collision. If there is a collision, we need to position the circle so that it's going to touch the surface of the globe. And to do that, first of all, we'll say circle.vil.x equals 0. We need to set the velocity to be 0 on both x and y axes. Then we need to find the new position of the circle after touching the globe. And to do that, we'll say circle.x equals globe.x plus the radii, which is the summation of the radius of the circle and the globe, and +1 to just put it on the surface, multiplied by, we need a new direction. Now the new direction is going to be exactly the opposite of this. So we can say const new dir, or the opposite dir, whatever you want to call it, equals dir plus math.pi, and that should be it. Because math.pi is like saying this angle plus 180 degree, which is exactly the opposite direction. And because we want to find the x component of this direction, we'll say math.cosine, then new dir. And same goes for y, but instead we'll say y, and radii, but instead here's gonna be sine. Let's try it out. Nice. It's working perfectly. Let's make sure there's no error. Okay, nice. Now let's try to change the position of the circle. For example, let's put the circle on 0x axis and 400 on the y-axis and try it out. Yes, it's perfect. It's perfect. Now let's try this. 120. Nice. Let's try 320. And it's working. Now I'm going to play around with the radius of the two circles to see how it's going to respond. Let's say the globe is going to be 100 instead of 80. And it's still working. Now let me push this to the bottom a little bit, 350. Okay, and it's still working perfectly. Let's put this to 10, and it's working. Okay. Alright friends, this is going to be the end of the first video of moving circle over circle, or circle over globe, whatever you want to call it. In the next video, we will implement the functionality so that the small one can jump and move over the big circle. Stay tuned until that time. Thank you guys for watching. This is Fahad from Game Code Bytes.